All right, future doctors, welcome. Today we're not just going to talk about some concept from a textbook. We are going to build the single most important mental model in all of medicine. Seriously, this is the bedrock for understanding pretty much everything from basic physiology to complex pathology.
So, let's kick things off with a really big question, one that all of medicine is trying to answer. Think about it. We live in a world that's constantly changing. It's hot, it's cold, we're stressed out, we eat different things, and yet inside our bodies, this incredible stability is somehow maintained. How in the world does that happen?
Okay, so here's our game plan for today. We're going to start with the problem itself, then look at the brilliant solution life came up with. We'll define the core principle, get into the logic of how it's controlled, and then, and this is the most important part, we'll connect it all directly to your future as a clinician.
To really get a grip on homeostasis, we first have to appreciate the problem it's solving. And the problem is this: staying alive is not a passive state. It's an active, non-stop process that's managed by thousands of beautifully coordinated control systems running every second of every day.
You know, the best way to think about the body isn't as one single thing, but as this huge society of cells, about 40 trillion of them. Each one is a specialist. You got your muscle cells, your neurons, your liver cells. And just like any society, it needs some law and order to work. It needs a stable, predictable environment.
So, how did life solve this massive problem of keeping trillions of cellular citizens happy and stable? Well, the solution was, frankly, genius. It created a protected, private little world for all our cells to live in. This private world is what the great physiologist Claude Bernard called the milieu intérieur. It's just a fancy French term for our internal environment, basically the extracellular fluid that surrounds all of our cells. Think of it like a private ocean. As long as the body keeps this internal ocean perfectly constant, right temperature, right pH, right nutrients, our cells can do their jobs without a worry.
And just look at this. The difference between what's inside the cell versus outside in that ocean it's night and day. This is absolutely not an accident. The body pours a massive amount of energy into keeping this chemical divide going because it's fundamental for everything from sending a nerve signal to making a muscle contract.
Okay, so this whole maintenance job, it has a name, and it's a term you're going to hear for the rest of your career, coined back in 1929 by the great American physiologist Walter Cannon.
And that term is homeostasis. Now, the key phrase here is nearly constant. This isn't a static, frozen state. No, think of it more like the thermostat in your house. It's constantly making tiny adjustments, kicking the heat on, turning it off, to keep the temperature in a very narrow, comfortable range. That's homeostasis. Every organ you have is part of this team.
To really appreciate just how amazing these control systems are, you need to understand that life is lived on a razor's edge. And when I say that, I am not kidding. The margins for error are unbelievably slim.
We all know this one, right? Normal body temp, 37 degrees Celsius or 98.6 Fahrenheit.
But check this out. Just a 7-degree bump? That can kick off a vicious cycle that literally cooks your cells to death. That's a tiny margin.
And blood pH? That's even tighter. We're talking a very precise 7.4. Because a tiny little shift, just half a pH point in either direction, can kill you. That's how critical these control systems are.
So how does the body pull off this incredible high-wire balancing act? Well, it's not magic, it's pure engineering. And it mainly uses two very logical types of control loops to get the job done.
The overwhelming hero of homeostasis is something called negative feedback. Its entire purpose is to promote stability, to bring things back to normal. Then you have positive feedback. It's an amplifier. It pushes things further away from normal, which, as you can imagine, usually spells trouble, but not always. Okay, let's walk through a classic example of negative feedback. Say your blood pressure shoots up. Special sensors in your arteries detect this stretch. They send an alert to your brain, which then says, "Whoa, too high." It sends a command to your heart to slow down and your blood vessels to relax. And what happens? Your blood pressure comes back down. The key thing here is the response is the opposite of, or negative to, the initial stimulus. It restores the balance.
All right, now for the flip side, the dangerous cousin, positive feedback. Instead of fixing a problem, this type of loop can make a system spiral completely out of control. We often call it a vicious cycle, and for very good reason. Take a major bleed, for example. Losing a lot of blood makes your blood pressure drop. Well, that means less blood gets to the heart muscle itself,
which makes the heart weaker. A weaker heart pumps even less blood, which makes the pressure drop even more. And you can see how this just spirals downward, right? It feeds on itself. Without some kind of intervention, that cycle ends in death. But, and this is really clever, the body has figured out how to use this incredible amplifying power for good in very specific situations. To form a blood clot really, really fast, or to generate the explosive force needed for childbirth, or to create that all-or-nothing nerve signal. Well, for those jobs, positive feedback is the perfect tool.
Okay, this is where it all comes together for you as a future clinician. This is the big so what. Let's talk about what happens when these beautiful, elegant systems break down.
I really want you to get this. Disease isn't some separate thing that invades us. At its very core, disease is a state of disrupted homeostasis. When we treat a patient, we're treating a body whose own control systems have either failed or have been completely overwhelmed. Your job is to become a detective of that dysfunction.
It's like that great quote from the textbook Guyton and Hall says, it's a two-way street. Every single one of those 40 trillion cells gets to live in this stable paradise, and in return, each one has a job to do to help keep it that way. Health is teamwork on a massive scale.
So I want you to burn this into your minds. You are not just fighting a disease, you are assisting a body. You are a highly trained engineer trying to help a complex self-regulating system get back on its feet. This single concept, homeostasis, is the lens through which you're going to view every single patient, every symptom, and every treatment plan. Master this, and you are well on your way.